Okay, welcome back. Happy Monday. Today is our 17th class of the semester. Today we're going to talk about something called linear regression. You'll notice here in the section column, it actually says supplement, so this is not something that's in your textbook. The homework on My Math Lab is going to look a little bit different because I think the questions were all created by one of my colleagues. In any event, something slightly out of the norm today, not in your book. Looking back, Project 2 was assigned a little while ago, and the due date is coming up October the 24th, which is 1 week from today. Again, you're welcome to work with each other. You are encouraged to work with each other on these projects. I think that you have all the tools that you need to answer all the questions on the project, so don't feel like you need to wait until the last minute. You could start it. You could potentially finish it well before 1 week from now. Also, quiz number 2 is due on Wednesday coming up. It is on your table, so go ahead and grab one copy of quiz number 2. In terms of prioritizing, currently you have a homework assignment that you're going to be working on tonight. You got the project you've been working on, and you got this quiz. The highest priority is this quiz. It is due 1 p.m. on Wednesday. You can turn in your My Math Lab assignment, and it's like 10% off if it's late. If you turn my quiz in late, it's 100% off, so don't do that, okay? I'm telling you what the priority is this quiz. The rules governing the quiz are written up on the top, but let's just make sure we are clear. You can use whatever resources you want for this quiz except the help of another person. This is one of the few things I give you that I don't want you working with each other on. This is all you. So you can't ask somebody in the math studio, you can't ask a classmate, you can't ask a peer tutor. You can ask me to clarify directions, but you can't ask me to help you on doing any of the math. What you can use is anything else. So that means our packets or your textbook or My Math Lab homework problems or random website stuff, anything you want, just not other people, okay? Again, that's due first thing at the start of class on Wednesday. Any questions on the calendar? Okay, so let's jump in here on page 61 at the top, here in our demo. Okay, in 1989, 44% of a country's population was on a weight loss diet. In 1997, 12% of the same country's population was on a weight loss diet. Part A, if we measure time in years since 1987, translate the given information into 2 points. Let's give this a shot. First one is here. Typically, if time is involved, is it the input or the output? Input, right? I mean, time is sort of independent of everything. And so we put it first, and then other stuff responds to time passing. So 1989, we're doing years since 87. So it's 2 years, yes? Comma, and then we'll put in the dependent variable slot, just the percentage. So I'll put 44. Don't, you could put 0.44 if you wanted, but we'll say that it's part of the definition. We'll just include the fact that that is a percent. Let's go ahead and write the other one. 1997, 12%. What are we putting? 10, 12. Good. Okay, and part B says find the slope of the line passing through the 2 points in part A. Okay, we can do that. So we're doing a change in Y over change in X, also known as rise over run. Okay, so we do 44 minus 12 up on top. Downstairs, what do we have to put? 2 minus 10. Just make sure you're consistent with the order. Doesn't matter what order you put on top, but use the same order on the bottom. Upstairs, that's a 32. Downstairs, -8. Reduce that if you can, -4. Okay, part C says interpret the slope as a rate of change in the context of this story. Be sure to give units. All right, let's start with the units. That's going to help us. The 44 and the 12 upstairs, what were the units there? Was it years? Yeah, it was percent up there, wasn't it? 44%, 12%. Downstairs, there was a 2 and a 10. 2 what? 2 years from 1987. 10 years from 1987. So just copying the units of my fraction over here as a fraction in the right order, percent on top, years on the bottom, I can just about say the sentence by reading this number with the units, -4% per year. Notice I got the word per in there instead of saying percent over years. Okay. So what does that mean? The negative means what? Decline or decrease, right? So something is decreasing by 4% per year. What's decreasing? Yeah, the population that's on, percent of population that's on the weight loss diet. Okay. So percent of the population on a diet decreases 4% per year. If I had done this, decreases negative 4% per year, is that all right? Right, what did we do to get rid of that negative sign? As we wrote the word decrease, you can't say decrease and negative 4, right? We already took care of the negative part. Okay, and then part D said find the slope-intercept form, which is this y equals mx plus b that we know and love, of the equation of the line, blah, blah, blah. So let's work on this one. So I'll just rewrite my mx plus b. Which of those 4 letters did we just find? Is the m, right? So y equals negative 4x plus b, agree? That's what we know. Really tempting for folks to say, oh, the b is a y-intercept, right? And so like the y coordinate of the first point we said was 44. And then just say, oh, great, I know the y-intercept, 44, right? What's wrong? Yeah, that's only when x is 2. That's not the y-intercept. And b is not just any old y coordinate. It's the specific y coordinate that's on the y-axis, which we don't happen to know right now. So we got to do work. A lot of students kind of forget. They think they should be able to just look at the points and fill in the b, but there's work. So let's do the work. Looking at the first point, the y coordinate we said was 44 equals negative 4 times, but that 44 is only when x is 2. And so we'll change the x and the y, both of them. And the b is still unknown, but it's about to become known. So we've done this before. 44 equals negative 8 plus b. B is 52. So then our final equation, y equals what? Negative 4x plus 52. That's good. Ivy? No, it's not divide, because there's a plus here. So the opposite of this negative 8 plus is to add the 8 to both sides. Yeah. Yeah, finding b is always going to involve either an addition or a subtraction. It's never division. Okay, E says explain the significance of the y-intercept. That's what we just found here. 52 what? 52% at the start, right? We got to get the start here. That's not just a 52% anytime. It's a 52% at the specific time when the x is 0, and in this case x is time. And so that means that in what's the x equals 0 year? 1987. 52% of the population was on a diet. Okay, so I think everything we've done so far is old. Like this is just kind of a review of stuff we've seen before. Potentially new, at least to us in this class, is this thing called the point slope form. Y minus y1 equals m times x minus x1. You've probably seen it in some other algebra class in your past. That equation right there is just an alternative to the mx plus b. And pretty much we exclusively use the mx plus b, but this is an opportunity for us to see that we'll get the same answer that the mx plus b gave us using this alternative form. Let's give this a shot. I'm going to fill in, I'm going to make some blanks here. Y equals a blank, or y minus something equals blank, x minus something. I got 3 blanks here, and we're just going to fill them in Okay, first purple. Purple is m. M is still the slope, which is what number? -4. So no change there. The two green things were symbolized with a y1 and an x1, and those are just the coordinates of either point that you have up above. Let's go ahead and use the 2, 44 that we used already. Which one is the y1? Yeah, we gotta make sure we get the y coordinate has to go over there, and then the 2 goes right there. And before we show that this is the same, that it's equivalent to the mx plus b answer we got, just be clear, there's something kind of fundamentally different about what we did with mx plus b and what we just did here. Which letters did we replace in this equation with the 2 and the 44? X and y, right? But down here, the x and the y got copied. We didn't change those into 2 and 44. We changed the y1 and the x1. Just a notational thing, but it is a difference I wanted to point out. Okay, this answer is fine if the question just says, you know, like write the equation, there you go, that's the equation. But let's just do a tiny bit of work to see it's the same -4x plus 52 we got up above. Let's distribute on the right. So copying y minus 44. Distributing over here, we go -4x and then plus 8. And then typically we solve for y, so what do we do to both sides? Add the 44. -4x plus 52, right? Which is the same as we got up above. So the point here, I mean, it's not that this is any better. I don't think it's any worse either. I think it's probably about the same amount of work either way to get to that final answer, but just showing you an alternative. That's called the point slope form. Okay, on the next page. Part G, write the equation in slope-intercept. All right, that's what we just did. Did it match? It did, of course it did. Yes, it has to match. Okay, and so then it says use the slope-intercept equation to predict the percentage of adults on a diet in the year 2000. So just, we'll write that equation again here so we have it. So in the year 2000, remember everything has been years since 1987. How much is X? 13, right? That's the translation we need. So what do we do with our equation? We'll just plug the 13 in for the X. Yeah, that is a 0, isn't it, right? Because -52 plus 52, 0. Okay, so according to our model, in the year 2000, what percentage of folks in this country were on a diet? None, 0. Yeah, and that means, remember it was decreasing 4% every year, right? So then in 2001, what's the prediction? -4%. So at some point the model has to break down, right? At -4%, it doesn't even make sense. Okay, let's see if we can answer part I. In what year was 50% of the country's population on a weight loss diet? So let's change 50%. Over here I said x equals 13 was the translation. What is it here? Y equals 50, that's it, right? The y has been the percentage this whole time. So we're just gonna go right back to our -4x plus 52, our equation, and just change the y to 50. Substitute 50 for y. Okay, so we subtract the 52. That gives us a -2. Divide both sides by the -4. X equals 1/2. Oftentimes when you find x, you're done with the algebra problem, but this says when. X equals 1/2 is not really a concrete answer yet. When? half a year after 1987. That's it, right? So I'll say middle of 1987. That's good. All right, so far so good? Okay, so now we're going to start doing something that might be a little bit new for us. So here's the picture of exactly the same data that we just saw. We know that we started at 52%, so that's this top point way up here. And if we decline 4% every year, then we just get this downhill, like it's a perfect line, right? There's some data points over there on the right. This was in GeoGebra. This thing was created. It's very easy to do. Okay, and we found the equation of the line, and that line would pass through every single data point just like that, right? It's perfect. We call that perfect correlation, where all the data points are exactly on the same line. But in reality, probably it's not perfectly negative 4% every year, right? You might have some blips. One year it's only down 3%, another year it's down 6%, right? The reality is definitely much more complicated than just a static 4% a year every single year. So here's some potentially more realistic numbers. So here's the brand new phrase, or word, I guess, scatter plot. That right there is just a scatter plot. A scatter plot is just a plot of data points. And so in this case, the data don't all fall on the same line, but they're pretty close to falling on a line, right? It's not perfect, but it's not like the data is just all over the place, right? It's fairly well concentrated on some downhill-ish kind of line, right? It's not perfect, but there's definitely a relationship here between time and what percentage of people are on this diet. So in number 5 is a line connecting 2 of the points. You see the 2 points? Looks like 244. It's only supposed to, well, it actually might hit 3. Let's see, 244 and 1012, and maybe it happened to also go through 724. So you could connect any 2 points you want, and you could say, hey, this line is pretty good. Most of the points are not that far away from the line, right? Great. So instead of connecting those 2 points, you could connect a different 2 points. You would get a different line. Here is a whole bunch of lines drawn, right? Mathematically, what we're interested in is the best line. I want the line that is as close as possible to all the points, not just the line that happens to hit 2 random ones perfectly, but I want to be as close as possible to every single point up here. So how do we find the best line, the line of best fit? So this says for now, we're going to let a calculator or a computer find the line of best fit for us. I just want to be clear that for now is the semester. I don't want you to like be holding out and then like on the last day of the semester, Ian, you promised me you were going to tell me. So I'm telling you right now, like we're not going to have the tools this semester to figure out what the equation of the best fit line is. If you take statistics or a calculus course, you will have those tools. But we do have GeoGebra, and we do have some graphing calculators we're going to use today. So we're just going to let the technology do the hard work for us. But I will tell you, this is sort of like the rabbit out of the hat thing, the best line, the absolute best line for those particular data points has that equation, y equals negative 4.3x plus 53.95. This is a really wishy-washy thing for a math guy to say that is the closest to all points line. Like I'm not really defining things at all here, but there is a very precise mathematical definition for what we mean by the closest to all the points, and that line satisfies the definition, which I'm not sharing with you. Okay, so there's the equation, and there's the line. How many points does that line hit? One, which one? 7,24, right? The other ones are definitely not on the line. Do you think 724 is actually like perfectly on the line? Yeah, I mean, like, how would you tell? How could you tell? I'll give you a hint. Looking at the picture is not the way. We got to plug in, right? I mean, that's the only way to really know. Is does 724 satisfy that equation? Well, it's easy to check. Instead of the y, we're putting 24. Instead of the x, 7. Okay, somebody with a calculator crunch this for us. Oops. 95. So what'd you get? 24 equals 23.85. So how many points are on the line? None. It's okay. I didn't say the line was going to hit a lot of points. I just said it's going to be the best line for all the points. In fact, in all reality, it's not going to hit any of the points in most cases. Okay, so number 8. Oh, by the way, so I was going to insert something in here. So this is not in your notes. I'm just going to, it's not right here in your notes, but I'm going to do this real quick on the calculator. So I'm going to lend out a bunch of graphing calculators today. A few pages down the road in this packet are step-by-step instructions for what I'm about to do. So like, don't worry about copying or doing it on your calculator now. It's in the packet. You'll read it in a few pages. So what I'm after here is to get this, the data points plotted, that line graphed, and that equation shown up on my calculator. So that's what we're going to do real quick. But again, this is just a sort of a sneak peek for what you're going to do in the activity. So the first thing we need to do is type in the data points. It's inside of this menu, stat, and then the very first option is edit. I've already typed in a bunch of them just so that you don't have to sit there watching me type them in, but I'll just type in the last one here. So 0 up to 9. So if I just type in 10 and hit enter, and then I can go to the right. What am I putting here? 12, and then hit enter. Okay, nothing complicated there. Okay, and then the next thing we're going to do is ask the calculator to plot those points. And so if I go into second stat plot, and I get this menu that maybe you haven't seen before, maybe you have, I'm going to turn this plot on. And the very first option looks like a bunch of dots. That's exactly what I want. So this is good. L1 and L2 are the names of the lists that we created before. So they're probably right as a default on the calculator you're going to use. And so I can hit graph. And what happened? Where are my points? Whoa. Yeah, they're not here. This is minus 10 to 10 on both axes. Where are these points? They're up here in the 50s, and right, and the 12 is the bottom. I'm not going to see anything. I'm not looking in the right spot. Okay, so we can change. How about we go 0 to, what's the biggest x? The biggest x is 10. All right, how about we go out to like 11 just so we can actually see the last data point. Let's go down here, 0 for the y. What's the biggest y? 57, so we can go up to 60 there. Go by tens, and if I'm looking in the right spot, I'll see the data points. They were there the whole time. I just wasn't looking at them. Okay, so there's the data points. This next sequence of commands is going to look complicated, but again, the steps are written down on your packet in a few pages. I'm going to go into stats, and then I'm going to go to the right to calc. And down here, linreg stands for linear regression. That's what we're doing here. AX plus B is what we're after. That's this circled thing. And I'll hit enter, and I'll hit enter, except I didn't hit the right button, so let's try that again. Calc, I meant to come down here to number 4, and then hit enter, and then hit enter, and we get that. How's that look? Negative 4.3, 53.95. Apparently this was rounded a little bit, but that's the calculator doing some magical calculations, and we're grabbing the answer, okay? The last piece to what I want you to be able to do on the calculator is get that line to show up. Now, what you could do is just come over here and retype that thing. But there's a couple of downsides. Number one, it's kind of annoying to retype, but number two, it's not going to plot the individual points.
If you put that right there, wouldn't you show like how the graph looks?
Yeah, it's gonna show the graph, but it's gonna keep those points there too. Yeah, it'll keep them both. But what's the problem with this line that's typed out here? Is rounded, right? This was rounded. And so if I really want to type everything, I got to type everything, and even there, it's not telling me everything. So, so there is a fancier way to get the calculator to give us the equation right here. And in fact, remember the steps I did to come up with this? I'm just going to do the same ones, but starting here instead of starting from the home screen. There's another way to do this. I'm pretty sure the calculator. Oh wait, sorry. Actually, I don't remember what your directions are in the packet. It might be this. I'm going to tell it L1, L2, and then the last thing I want to tell it is where to put the thing, put it in Y1. And so I hit enter. This looks exactly the same, but now miraculously it's typed everything in for me. Right. Okay, so I know that was quick. Again, the steps are written out. It's also here on the YouTube video, which you could check out later. And if I hit graph, it's going to show me the points and the line. Good? Okay, last thing to say, and then you'll do the activity. Is right here. There's this thing called the correlation coefficient that measures how well the best fit line or regression line fits the data. In fact, the calculator may or may not be set up to give it to you. If it were going to give it to me, it would have given it to me here. There's some fancy way. I haven't done this in forever. I apologize. I'm looking for this phrase that says diagnostic on. And if I do that, it says, okay, done. But then if I ask it to do exactly the same calculation, now it gives me some more info. Same negative 4.3 and 53.95. But now it gives me these two numbers here, r squared and r. Okay, we're not going to pay attention to r squared for right now. We're just focusing on r. It's this number, negative 0.98. It's pretty darn close to a nice number. What nice number is it pretty close to? Negative 1, right? Yeah, negative 0.98. Okay, so here's what's going on. If the data points were exactly on a line, the R value you would get is exactly negative 1. So negative 1 means it's perfect and it is downhill. If it had been uphill, you would have gotten R equals positive 1. So the sign of R tells you whether the slope is positive or the slope is negative, okay? If it's perfect, it's either going to be R equals 1 or R equals negative 1. If it's not perfect, but it's close, you're going to get a number close to 1 or negative 1. So that negative 0.98 is pretty darn close to perfect. Sort of makes sense because the data points are pretty close to being on the line. So here it says something, so I guess we're looking at a picture like this. Downhill, not perfect, but pretty close. You'll get something that is close to negative 1, but not exact. But then you might have just this blob of data. And I can't look at that blob of data and say, oh yeah, there's like a nice uphill line I can draw through here, or a nice downhill line. It's just a blob, right? Just sort of like random dots on the graph. And in this case, let's see if we can test our intuition. We said R equals 1 will be perfect uphill. R equals negative 1 will be perfect, but downhill. What about a blob? 0. It's like the farthest we can get from being a perfect 1 or a perfect negative 1, okay? So every time we do one of these calculations, your R for sure is going to be between -1 and 1. The closer to one of those endpoints, the better the data points are for fitting on a single line. But if the data points are just like this amorphous blob, you're going to get numbers close to 0. 0 means there's really not much of a relationship there, okay? All right, I think that is that. So the class activities start here. At some point, you're going to get to the place where it says borrow a graphing calculator if you don't have one, and then you'll just do the same routine with your cell phone. And I might jump people forward at some point to get there too.